Okay guys, so here we are, lesson 11.7. We're going to find the surface areas and volumes of cones. So surface area is something that we actually haven't discussed yet. A surface area is the area of all of the surfaces of our figure. So when we're dealing with a solid, let's say we're dealing with a polyhedron, which means again that all of the faces are polygons. If we were to unwrap that, meaning if we were to like unfold our, let's say we had a cube, we would have something that looks like, again, each of these would be squares, but we would end up with something that looks along the lines of this, where we have 6 congruent squares, and this is our flat surface. This is known as a net, okay, if we were to like unfold it. So the formula for finding surface area of any polyhedron, again, where each of your faces are polygons, is that you find each of the polygons and add them up. So you find the area of each of those and put them together. That's not too bad. I mean, it can be a little involved, but it's very doable because you just find the area of the polygons. Now, what we're going to take a look at in this lesson is this solid, which this is not a polyhedron because this area around the outside, this smooth area, is not a polygon. If we unfold this, let me show you what it would look like. If we unfold this, it ends up looking like, let's clear that, this. So again, we had a cone, okay? So the bottom is the circle, and we see that here. But then whenever we unfold this portion, I saw it described once as a party hat, and that's what we would look at if we were doing this in class. If you happen to have a party hat at home, you can try it. Along the staple or seam, whatever they have, their glue, unfold it, and you'll get something along the lines of this here. Okay, it kind of looks like a Pac-Man looking image. Now, this whole description, and this is in your book if you want to take a look at it, it explains how this is my area of my sector. This is the sector of a circle, remember? So I'm finding the area of this sector. They explain how to find the area of this sector, and luckily it boils down to something pretty simple. Pi times the radius times L. So let's talk about what L is. Okay, so back to our page. Let's clear everything we've done so far. Surface area of a right cone. Right meaning that it is right angle right there. Okay, so that Cavaliere's principle isn't going to apply to surface area. That would make things a little different. So it has to be a right cone. So the surface area S of a right cone is given by pi r squared. So that's the area of my base, that circle, okay, plus pi r L, which we just saw is this Pac-Man looking image. Okay, so we know that R is our radius. Now L is something new. L is the slant height. So it's not the height of the cone, it's the height of the slanted side. So L, okay? All right, so let's try a couple. If we're using this formula, all we're going to have to do with a good number of these is just substitute in the information that we're given. All right, so pi, if I look at this cone to the right, I am given a radius of 4. So 4 squared plus pi, with still the same cone, so I still have a radius of 4, and my L, my slant height, is 6 inches. Okay, and I haven't been mentioning it, but always make sure you have the same units, otherwise obviously you're not going to get the right answer, you'll have to convert something. But we've had that, luckily. These are just practicing the concepts, not trying to trick us. Anyways, I can simplify that. 16 plus 24 we know is going to be 40. Okay, so I can leave this answer as 40 pi and label it with inches. Now we're doing surface area, so it's inches squared. Or I can go ahead and do 40 times pi, and I can get 125.66. And label that inches squared. And that's rounding it to the nearest hundredth. So depending on what the directions are ever asking you and whatever scenario you might be doing, just pay attention to that. Okay? All right, that's all we're going to do with surface area here. Now we're going to move on to volume, which we've been doing. And again, this is when you fill up, if you think about like a cone, maybe more like that, like an ice cream cone, it's how much ice cream can fit in there. Okay, good time of the year to think of it. They just show you how the formula comes to be. If you take a pyramid, we know the formula is 1/3 the area of the base times the height. Now as we add more and more and more sides to that pyramid, it starts to take on this curvature that almost creates a circle. Not exactly, but that's somewhat of an example of why the formula is going to turn into this. pi r squared h. So instead of capital B, it's pi r squared, which isn't that the area of our base? Yeah, so it's essentially the same thing, just a little more spelled out. Okay, so next page, volume of a cone is 1/3 the area of the base times the height, or 1/3 pi r squared h. And just like we had said when we did pyramids related to prisms, if we were in class, I have a cylinder, and I also have an equal base cone, so like this might be radius of 2 inches, and my cylinder has a radius of 2 inches. If we fill up our cone, it's going to fill up my cylinder this high, which is kind of cool. Okay, so if you're looking for an Amazon gift, maybe you could Google equivalent solids and do your own experiments at home. Anyways, here's our formula. Either one will work because they're the same thing. This one's just a little bit more spelled out. And notice we're talking about volume, so this Cavalieri's principle applies here. It only applies to volume. So we can go ahead, it doesn't have to be a right cone. That said, same cross section here. If I had a cone, I think of a slinky, with a cylinder, I can slide it and I still have the same slinky in the end, same concept. All right, so anyways, find the volume of a cone. I'm going to use the 1/3 pi r squared h, because that's what I have to do anyways to fill out the area of the base. So 1/3 times pi, my radius is 2.2, that's squared, and my height is 4.5. Okay, so I'm just going to multiply first 2.2 squared times 4.5, and then divide that by 3, or multiply by 1/3. And this is going to give me 7.26 pi. So again, that's one answer that I can leave it as, making sure to label. Now we're talking volume here, so I have to label it centimeters cubed. That's one answer, or I can go ahead and multiply this by pi. And when I do that, I get 22 and I'll round that up to 81. 22, this should be about approximately 22.81 cubic centimeters. So either of these answers are good. Okay? All right, let's move on. Let's try practicing again. So volume is 1/3 pi r squared h, 1/3 pi. My radius is 7 squared, and my height is 13. Okay, so if I just multiply 7 squared times 13 and divide that by 3, I'm going to get 212.3 repeating times pi. So this is inches cubed, which is about 667.06 inches cubed, either or. Okay, all right, so now let's try one more. In this one, just a tiny bit of extra work, but not too much. 1/3 pi r squared h. I know my radius is 5, so it's 5 squared. What I don't know here is the height, so I'm going to figure that out. But this is a right triangle. Right triangles never go away. I know some of you are smiling at that. 5, maybe more of you than you would like to admit, because they're great. Anyways, Pythagorean theorem, we have 5 squared plus, we'll call that x, or h. Let's just use h. H squared equals 8 squared. And if I go ahead and solve this, 25 plus h squared equals 64, and 64 minus 25 is going to give me 39. So h, and I take the square root of that, h is equal to the square root of 39. So I'm going to substitute that in here. All right, so I have the square root of 39 is my height. I'm going to multiply that by 25, which is my radius squared. I'm going to divide that by 3, same as multiplying by 1/3, and I get 52.04 pi. That's meters cubed. Or if I multiply it by pi, I'm going to get 163.49 meters cubed. Okay, so those are just practicing finding volume. Let's go ahead and look at similar solids, which we've already done. So I'm going to say this is my original, this is my new one, or if you like it better, you could say pre-image, and this is my image. Okay, whichever one clicks better for you. So when I set up my scenario here, I'm going to go in my scenario, my situation, what we have all along, I'm going to go from A to B, so towards the right. So I'm going to put my image as cone B, so the volume of cone B over the volume of cone A is going to equal my scale factor cubed. Now when I do my scale factor, I have to do again my image over my pre-image. So I have a radius of 9 over a radius of 3. So 9 over 3. Okay, now let's substitute what we know. We don't know the volume of cone B, so it's my unknown. I do know the volume of cone A is 15 pi. I can simplify this to 3 cubed, which is really 27. So x over 15 pi equals 27. It's like 27 over 1. So when I cross multiply, this is really just going to be 15 pi times 27, and multiplying that. They want their answer, they left their volume in terms of pi, so I'm going to leave my volume in terms of pi, and I'm going to write this as just 405 pi feet cubed. Okay. All right, so there we have it. If I can leave it like that because that's how they left it, but if you want, you can multiply it by pi and you get 1,272.35 feet cubed. All right, we have one more page, and this is taking a look at composites. Okay, so I'm going to find the volume of the cone. I'm going to add it to the volume of the cylinder. Okay, volume of a cone is 1/3 the area of the base times the height, so pi r squared h. The volume of a cylinder is just the area of the base times the height, so pi r squared h, but no 1/3. Okay, so these are essentially the same thing. Let's just sub in what we know. 1/3 pi, my radius for both the cone and the cylinder is going to be 6. So 6 squared, and the height of my cone is 4. All right, now if I move on to my cylinder, looking at this bottom part here, so now I'm doing this portion, I have the same radius, which is 6, but the height of this is only 5, or which is more, but all right, let's simplify. 1/3 pi times 36 times 4 plus 1/2. Why did I write 1/2? Where did the 1/2 come from? Sorry, if you were watching that, you're probably thinking, what did she just write? And I don't know. That should have been pi times the radius squared h. So there we go, pi 36 times 5. Oh, I'm glad we caught that. Okay, whoops. Oh. There we go. All right, 1/3 in 36 is 12. 12 times 4 is 48. So I have 48 pi plus 36 times 5 is going to give me 180 pi. So if I add these two together, I get 228 pi meters cubed, which is approximately 716.28 meters cubed. Okay, so it's just doing them in pieces. All right, let's try one more. I think we can squeeze it in. So we're going to find the volume of the cone and add it to the volume of the cylinder. Same formulas. 1/3 though goes in front of the cone, pi r squared h, the height of the cone, and then we're going to add that to just pi r squared h, the height of the cylinder. The only problem with doing the formula like I have it here is that it implies that h is the same, and it's not. It's different based on what solid you're talking about. So as long as you're close and paying attention to that, you're okay. All right, I think we're close to the end. I'm going to do this real fast, at least set it up. My radius is 3, so 3 squared. The height of the cone is 5. All right, and now I'll do this in a different color. This one's going to be pi. My radius here again is 3, so 3 squared, and my height is 10. Simplifying it a little bit, I have to simplify this first before I cancel anything out. So 9 times 5, this is going to be pi times 9 times 10. Okay, I'm going until that little arrow tells me I'm done. 3 times 1/3 of 9 is 3. 3 times 5 is 15, so 15 pi. And then I get 90 pi, and if I add those, I get 105 pi. And 105 times pi is about 329.87, and that's centimeters cubed in both cases. Okay.